Hello everybody and welcome to my SQL Bits 2020 session. My name is Paul Andrew. I'm a Principal Consultant, Solution Architect and Data Platform MVP. In this session, I want to talk to you about data flows, but we're precise people, so let's not have any ambiguity here. I want to talk about data flows within Azure Data Factory. And what I'm hopefully going to do for you is make the argument that these new features that we have within our data factory are going to make ETL, extract, transform, and load within Azure easier for us. And we'll look at some use cases and try and evidence this in this session. So before we dig in, as you may know, or if you've seen me speak before, I have a community events repository that's up in GitHub, and there's already a PDF of these slides up there, so feel free to go and take a copy of those visuals if you like what you see. Now, before we actually get into the data flows and get into Data Factory, I want to try and establish a bit of a baseline, and this might seem obvious when we're working in Azure in a cloud environment that is highly scalable, but I'm going to use this in a few of my arguments as we go through. So firstly, I want to talk about scaling up versus scaling out. And a really simple scenario for that, we have some work, some data that we need to process, and we have some compute to process it on. Very generic here. And what we can do is we can say, well, the compute isn't enough, we need more power, and we can scale up that compute. So within that single compute node, we increase the size of the CPU that node has. So we scale up the compute. Or we go the other way and we scale out that compute. Maybe a little bit, maybe a lot. And here we have that separation or that distinction between scaling up that one compute node and scaling out or distributing that compute. And this is just something that I want us to understand firstly as a baseline. We can, of course, only scale out if we want. If we want to make that decision, we could just have small amounts of compute on each node, but distributing them, fine. Or we might want to do something in between to try and find that sweet spot of scaling up and scaling out. So that's it. That's the first point I want to make. Scaling up versus scaling out. Obviously, a fairly simple one, but just as a baseline. Now let's turn our attention to Data Factory. And for those that are new to Data Factory, just a very quick intro of what Data Factory is and why we might use it. So what I've done here is just put together a timeline for you, so a quick history lesson of Data Factory. Now, I've been using Data Factory for the entirety of this timeline. So when it was in sort of private preview way back in July 2016, and version 1 of the service, it was not a happy Data Factory, but it was there and it was what we used to orchestrate our other Azure services. Now, the service has come a long way since then. It is now very feature rich. And what's quite pertinent for this timeline is that data flows actually were only introduced to Data Factory, or I certainly only saw them in March of 2018. And when I say here that they were the alpha version, this was over in Redmond at Microsoft HQ, and Data Factories then were nothing more than a set of mock-ups in a PDF file. So just some sort of basic screen layouts of what mapping data flows were going to actually do. So although Data Factory as a service has come a long way and is quite mature, we could say that the data flow features within it are still maybe quite new, certainly the Wrangling data flows, as we'll see later. So quick history lesson, just to bear that in mind. Now, if we change the question and say, well, what is Data Factory? And we go to the Microsoft site, which changes every time I look at it, we now get this very pretty 3D version of our Data Factory, which for me looks more like a steam train than a cloud service. But anyway, and the marketing people have done their usual thing of trying to describe to us what Data Factory is. And I do sympathize with them actually in most cases, because Data Factory, as you saw in that timeline, it has come a long way. It is now a fairly mature service, and there's lots of things that it can do. So trying to describe it, on a single sort of paragraph here on a website, you can see they struggle. But the takeaways here, if you've read through this, and I have, is integration. we can hopefully take away here that Data Factory has got something to do with integration, given these descriptions. Now, that's the Microsoft version. I'm not going to read it to you, but what I will do is give you my version of what I want to tell you Data Factory is for those that don't know. And if we have some process, some data that we want to get from A to B to C as data engineers maybe, Data Factory will sit there as the umbrella service, or as the orchestrator, as I like to call it, and it will orchestrate that process, allow us to monitor and manage and schedule that data as we do whatever we need to do with it. Now, if we actually go a step further, we actually look inside our Data Factory at the components we need to achieve that. This is what we have, the 5 core components of Data Factory that we're going to start with. And those are our link services, number 1, which will allow our Data Factory to connect, to authenticate, to communicate with whatever service we're going to go and work with at the time. Number 2 will be our data sets. So this is a metadata representation of the thing that we're going to go and work with. And our data sets will authenticate using our number 1, our link services. Then number 3 is this idea of an activity. So an activity will be information specific to the service that we're going to go and invoke. And that will again authenticate using our link services, number 1. Number 4 is this idea of a pipeline. So we could say that everything I've got here between my orange arrows is a data pipeline. And yeah, fine in that context. But also be aware that a pipeline is a component of Data Factory. And what you'll hopefully gather from my dotted lines and boxes here is that a pipeline will allow us to group together our activities. We can put them into logical groupings if we want, of however we want to create our Data Factory. We could maybe have a pipeline for all of our data ingestion, then maybe another pipeline for all of our transformation. It's up to us here how we do that. And we can, of course, have multiple activities within a pipeline. Then number 5, finally, we have this thing called a trigger. So a trigger will attach to one pipeline or many pipelines, and it just allows us to then go and tell that pipeline and the activities within it to go and execute. And we can do this in a few different ways, using tumbling windows, by subscribing to file events in blob storage. The file's been created, go and trigger my pipeline, or using perhaps the more conventional recursive schedule of things that we say happen daily, happen weekly, monthly, whatever. So those are the 5 components of Data Factory that I want to introduce to you for now. And what I'm going to do is a bit of title maintenance. I'm going to say that these are our control flow components. And given the nature of this session, I absolutely want to draw some comparisons here between our SSIS packages that we may or may not have been using within the SQL Server environment, and that distinction we have within a sys package between the control flow plane and then later what we'll have as the data flow plane. So these are our control flow components within our Data Factory to orchestrate this process. So now let's move on and let's remove those transformation parts to this process that I've put before you. And what we can now do is introduce our data flows. So what we could do is use data flows in place of those transformation activities to do whatever we need to do. And like the activities that were there before them, our data flows are now their own activity within our Data Factory that will allow us to do that data transformation work. So instead of just thinking about we're copying a file from A to B at a data set level, these data flows are now going to allow us to actually get into the rows of that data, to the actual attributes or the columns that are in there, and do transformation at that value level within our data if we need to. Now, what you might be thinking is that, okay, I'm working within Azure. I have already a lot of services to do data transformations with. Why would I use these new data flow capabilities within Data Factory? And just to kind of really sort of emphasize that point, I put together this slide of what other data transformation services do we have within Azure. And hopefully, as you can tell by this slide, there is a lot of options. And given enough pain, blood, sweat, tears, and battle scars, which I think I have, we can, of course, argue and then eliminate some of these and say, well, yeah, that's not right. We probably shouldn't use that in that case. And, as an architect, start thinking about which of these services we do want to use to do our data transformation. There's obviously some obvious ones here that our sys packages over on the far left, we might say that they can only scale up on the infrastructure that Data Factory provides us using that SSIS IR, but maybe that's a conversation for another time. We could say that HD Insight is going to mean we're going to have to manually configure clusters and deal with that distributed compute that we might not want to. We could say that Data Lake Analytics, which is really just an abstraction over HD Insight, is, as we rumor to know, that is going to be deprecated by Microsoft. So, of course, let's not use that. We have our relational tools as well, our SQL DW, which has now, of course, been rebranded within the Synapse suite of services. And we might say, well, do we really want to redistribute our data sets on that DW storage? So, you can see here, if we go from left to right, we can start to pull apart each of these and figure out really what our requirements are. And the unfortunate answer to a lot of this stuff, if you say to me, well, which service should I use? The answer is always going to be, it depends. And it really will. The ones on the far right, hopefully analysis services and Cosmos, we can hopefully eliminate those quite quickly and say, yes, they might be able to transform our data, but probably not quite the right services. The two that we have there for Synapse and Databricks, both using Spark, now, yes, those are good contenders. So we'll probably explore those a little bit more, as you'll see soon. And then just to cover off what we have left on here, our batch service and our durable functions. Now, in either case, we're going to need to write our own custom code to do that transformation work and then implement that code either in a serverless function environment or using the batch compute pools, which is kind of just an abstraction over some infrastructure. So lots of different questions and things that we might need to consider. But of course, in the context of this session, what I want to do is then pose the question of, well, when should we use data flows? We have this new capability, how does it fit in this landscape of all these other tools that we want to work with? So I'm not going to answer that question straight away, but let's now go into mapping data flows and start exploring this with a view to answering that question later. So let's say, what is a mapping data flow? And I'm going to start with that control flow plane that we have within our data factory. We have perhaps a pipeline that has a data flow activity in it that is going to go and be executed on our Azure integration runtime. So that's at the control flow level, fine. At the data flow level, this is what we have in the form of a very simple mapping data flow to begin with. I've taken two data sets, I've joined them together, I've aggregated them, and then I've produced the output. Really simple, but of course doing that row level transformation. Now, at our control flow level, that activity will give us the JSON output that we can work with. At the data flow level, what we get as the output is a script file. Readable, but obviously quite specific in what its purpose is. Now, the exciting thing and maybe the interesting thing about that script file when we think about the data flow is that that script will be taken it will be converted to Scala, and then it will be compiled as a jar file and passed to Spark to execute. Now, as you may know, Spark is this very rich analytics ecosystem with distributed compute and cluster management and all these other nice things that we have wrapped up there. So what we could actually say is, to try and answer this question of what is a mapping data flow, we could say that maybe the answer to that is that a mapping data flow is a graphical data transformation tool that sits over the top of Apache Spark. Now, obviously, that's quite an interesting abstraction that we've got there. We've got this graphical environment where we can do our data transformations, but we've then got the powerful backing of Apache Spark and its ecosystem and its distributed compute that sits over it. So let's stick with that as an answer for now. And there's absolutely some arguments here as whether that's a good thing or a bad thing. There'll definitely be some hardcore Spark people out there that say, no, this is terrible. This is using some Microsoft secret sauce, and that abstraction is just an abstraction too far. We don't want that to happen. We should, if we're using Spark, we should be into the code and doing it properly. Why do we want this graphical UI? Well, let's try and answer that. So let's go into our mapping data flow, and I'm going to change the question again. I'm going to say, well, what can a mapping data flow do? Why is this a good thing? So let's start with our inputs and our outputs. And what we have in Data Factory, if you ever use the copy activity at the control flow, we have this idea of a source and a sink. Not a source and a destination, it's a sink for some reason. Now, at the control flow level, Data Factory can, I think, connect now to sort of 90 plus link services. It really can talk to anything. At the data flow level, we are a little bit limited at the moment. And that really is because we're using Spark in the background to connect, and then we're writing that Scala. So our ability to connect to things is limited. And at the moment, data flows, mapping data flows can connect to these handful of Azure services. And going one further, if we do happen to pick one of those as the storage, our data lake or our blob storage, we are further limited to the source files that we can connect to or the format. Now, does that really matter? At the control flow level, we can connect to lots of things. We could copy and bring that data in to our data lake store maybe, and then we can start building our data flow. So it's not really a restriction, it's just something to bear in mind at the data flow level that maybe we need to do that sort of pre-copy from a different, more exotic link service first. So that's the first thing to bear in mind, our inputs and our outputs. If we go one further though and actually look at what that source and sink can do, we do get quite a nice set of options. We can handle schema drift and validation, because we are now looking at the row level data. We can infer those column types if things change over time, which gives us a bit of flexibility. That's quite nice. And we can do things like true data move operations where we do delete what was on the source side before we move it to the sink. So a few things that are quite nice, certainly features that we don't get at the control flow if we were using a copy activity on its own. These are things obviously now that we're into that row level transformation that we can work with. As for the transformations themselves, this is what we currently have available. All of these can be used within our mapping data flows, and maybe just to kind of disambiguate things again, what we have here is a lookup transformation, which of course is very much in the spirit of joining maybe our surrogate keys and resolving them when we're perhaps loading a data warehouse. So the lookup here is that kind of join transformation that we're perhaps more used to within a sys package. This is not the same as the lookup activity that we get at the control flow level. So just bear that in mind, obviously two different purposes there. So these are our transformations. obviously categorized according to what Microsoft say, with the purple, the green, and the orange, and that's fine. Obviously got a good starting point. We can obviously do quite a lot here with our data at this level if we need to, all in a very graphical way. Next, let's move on and turn our attention to Polybase. And say, well, okay, Polybase, how does that fit within our mapping data flow? Well, what we can do is that if our sink happens to be a Synapse data warehouse, where we actually need to put that data. Now, as we probably know, the fastest way to load that data warehouse technology is using Polybase. Now, what the mapping data flow activity does and makes very easy for us is it introduces this idea of staging. And what staging will do is, behind the scenes, you'll define it at the activity and say, use this staging area, which will be some blob storage that you have available to you. And it will, from the mapping data flow, it will copy that output to that staging area, to that blob storage. And then within our data warehouse, it will create the external tables, the external file sources, and all the bits and pieces it needs to be able to use Polybase to then load that data warehouse. So obviously that's quite a nice optimization that we get out of the box via this UI just with a few clicks. So something to bear in mind that makes this easy, certainly within our mapping data flow. The next thing we have at our data flow level is an expression builder, certainly something that we're used to at the control flow level, adding that dynamic content. But now the expression builder, of course, is much more focused around that data transformation work. And we can do some nice things in here around regular expressions and obviously our aggregations, our counting and our sums. We get that capability within the data flow expression builder, which is definitely something that we come to expect from a sys package. We can also handle partitioning. Again, very easy via this data flow UI. We can say for a given transformation, how do I want the partitioning to be handled? Do I want to use the default 200 odd partitions that Spark is going to give us? Or do we want to do something a little more niche depending on the data that we're working with? Now, this partition handling will get put under a tab within our data flow activity called Optimize, which is spelt wrong, but anyway. And what that Optimize tab will also do for our joining transformations, it will also allow us to broadcast that data, so keep it in memory for those joining transformations where we need to. So we don't need to do anything here complicated with code. We can just say Optimize and then deal with these broadcast and partitioning things as we need to. So some really nice capabilities there that we get through the UI. We can, at the data flow level, do debugging. Now, once upon a time in a sys package, if we were doing transformations and lots of them, and we actually wanted to see what that data was going to look like, we would be doing multicast things and outputting things to data viewers and to trying to look at that data as we went through. Well, now what we get within our data flows is the ability to warm up a Spark cluster and say, okay, debug my data, but really what that's going to give us is the ability for every single transformation to actually look at that data as we go through. So we can see what's happening to that data throughout that transformation, which is really nice. We can provide sample data sets as well. So if we've got a subset of our data, a smaller data set, without sort of churning through terabytes of it, we can provide that sample data in debug mode and build out our transformations very quickly. The last thing that our mapping data flow can do is its monitoring capability. Now, this is something that's really quite nice, and what we'll do is, if we run our data flow in debug mode, we will have the simple mapping data flow transforms that we've seen when we've built them. But then what will happen is, at the control flow level, when we ask Data Factory to go and run this, it will then give us what I've put in the bottom right of this slide, is this sort of pseudo representation of that data flow. And this will be a parsing and a digestion of those Spark logs that Data Factory has brought back and said, okay, for each of these transformations, what happened? How many rows were there? What partitioning was used? So you really get this sort of quite nice monitoring capability as well out of the box within that mapping data flow. Okay, so let's take a look at it. So let's switch over to Edge. And what I've got here is my Data Factory developer UI. And I'm going to very simply create a new pipeline. And from my activities, I'm just going to bring on a data flow activity. I'm going to say I want a new mapping data flow. And then I'm just going to build out basically what you saw in the slides. So I'm going to add a source called order headers. The source type, I've got this drop down box. So I'm going to use a data set, but you can of course see here that things like Delta tables, Excel are common data models are also supported, but I'm going to be boring and use a data set for this demo. I've already got my data sets pre-created, so I'm just going to use a couple of Parquet files that already exist in my data lake. I don't need any schema drift at this point. That's good enough for my first source. I'm then going to add my order detail lines, also a data set, also one that I've cheated and already got in my lake. I'm then going to add my first transform. So this is what we saw in the slides, this big list of them. And I'm going to join those data sets. So I'm going to join my order headers on the left to my order detail lines on the right. I'm going to use an inner join, and I'm going to use the sales order ID to do that. All good. Next up, we're going to aggregate, and I'm going to group by the sales order number. And then I'm going to specify that aggregation. I'm just going to say order line count. And then I'm going to break out that expression builder. So this is the current expression builder experience that we're going to get. And I want a count expression, and I want to count from my input schema the sales order detail line, so the primary key of that order line data set. So I can save that. Then what I can do is, you may have noticed, I've already got my debug cluster turned on. I've already got this warmed up just for demo purposes. But having that debug cluster sat there, I can preview that data, I can hit refresh, and it will already sort of go and inspect that and do this work for me and actually look at, okay, well, what's my data set going to look like given this aggregation that I've asked for. So I'll just give this a few moments to fetch that data. So let's come back. So we can already see kind of what my expected output is from this aggregation, which is fine. So I'm then going to just add a sink, and my sink in this case is going to be another data set, but this time going to a SQL DB database table, which has got 2 attributes in it already for those records. What I'm going to do is, in my settings, I'm going to say truncate that table. So you can see I've got that pre and post execute scripts here, and I've got, if we want, I can also create the tables at runtime if it doesn't exist, which is nice. I'm going to truncate in this case. Absolutely, inserts are allowed. I'm then just going to look at the mappings. So what Data Factory will do is it will implicitly map columns that have the same name, but I've deliberately not done that. So I'm going to say, don't use auto mapping. I know they're going to be different. My sales order number is fine, that is the same, but in my aggregation I called it order line count. So I just need to map that to my record count on the right hand side. All good. So then that's basically my data flow done. I already know what it's going to look like. So what I'm going to do is I'm just going to save that, and then I'm going to go back to my control flow level, to my pipeline, and I'm just going to debug my data flow debug session. You might have saw that I can debug this using the activity debug environment. That takes about, in my experience, about 5 minutes to sort of warm up that cluster and do that debugging. So I'm just going to use my data flow session that I've already got available here. And this will take about a minute or so to run. So I'm just going to shut up for the recording and see if there's any questions that need to be answered while furiously hitting refresh. Okay, 30 seconds. Maybe no questions then. Let's move on. So what I want to show you is that from this sort of cold data flow that I've just created and that I've just ran, I can now preview this. I can look at the data flow. And this is the monitoring screen that I was talking about. So we have our source data sets coming in. We have our join, fairly boring. But what you can also see is that here, for my aggregation, it is only 2 columns, and we are dropping 27, but I do only have 32 rows here. So, these are demo-friendly data sets, but I've got 32 rows, which it's now attempting to distribute across 190 partitions. So obviously complete overkill, but that's what it's done by default. Similarly, with the sync, we have those 2 columns, and we're doing that same sort of partitioning as well. So you can see I've got 1 row for lots of those partitions, so definitely not optimal, which is fine. So that took 33 seconds to run, obviously very small data sets. What I'm now going to do is I'm just going to turn my attention to, here's one I made earlier. So this is another pipeline and another data flow, the same data flow as what I just created. I've obviously been a bit cleaner with my namings on this one. But what I've also done is I've gone through this data flow and I've optimized it, spelt wrong, but I've said, because my data sets are only small, just use a single partition. In my join, I've said, yes, please go ahead and broadcast this data, because I know that the data sets are only small, they can stay in memory. I'm using a very small general purpose cluster in my integration runtime with 4 workers. But we can say, yeah, fine, broadcast this, use a single partition again. There's no point partitioning here. What I can do if we want for my aggregation, I know I've got 32 rows, so I've said, yeah, fine, just round robin those 32 rows on 4 partitions. That's probably not even necessary, but it just demonstrates that we can do this very easily. And then lastly, for my sync, just use a single partition again, because there's no point here. We can quickly make these adjustments in this UI. So now for here's one I made earlier, let's debug that and just see how it compares. Now, if I frantically hit refresh, it will make it go faster, as of course we all know. So this should take sort of 15 to sort of 17, 18 seconds, he says, to run. Maybe a little longer this time, of course, because I want it to. So my pre-created mapping data flow has now ran with those optimizations. Annoyingly, it took 33 seconds. When I was doing this before, the gains actually were a little more significant than that, although we're of course dealing with very small amounts of data. But if we look at that monitoring again, we can see that we've got the same results, but now for things like our aggregation, we're using those 4 partitions, which of course is a lot more efficient for the small amounts of data we're working with. The point really here is, though, that although my data is small, we can optimize our transformations very quickly. So if we're doing some heavy lifting, we can quickly make those tweaks within this UI and then reap the benefits of them. So that is our mapping data flows, a quick intro. Let's now turn our attention back to the slides, and this time let's think about our wrangling data flows. So with our wrangling data flows, this is what we have. Very much the same sort of thing, and I've done this very deliberately in the slide. We have our control flow plane as before, but now what we have in our wrangling data flow is something that looks a little bit like this. And as hopefully you'll notice, this is very reminiscent of what we get within Power BI with our Power Query capabilities. And as with our mapping data flow, we will have a script output that will be converted into Scala and passed to Spark for execution in very much the same way. Now, if we say, like before, okay, this is our wrangling data flow. It looks like Power Query. What can our wrangling data flow do? Well, what, of course, we can do is put that side by side with Power BI, and the very simple answer to what can our wrangling data flow do? Well, almost anything that Power BI can do. Obviously, the feature parity isn't quite there yet for everything, but we do still have quite powerful capabilities here in this preview feature in Data Factory. So what I've done for you in these slides is just compare our toolbar, our ribbon, if you like, with the capabilities in our wrangling data flow versus what we get in our Power BI Power Query. So on our Home tab, the usual suspects with refreshing and removing columns and things like that. Obviously, the Power BI has got now these sort of Azure machine learning options as well. Not quite there in the wrangling data flows, but very, very similar in terms of what we can do. On the transformation tab, again, the usual suspects of merging things and grouping, doing those aggregations. We see in Power BI that we can now, of course, run R scripts and Python scripts, not quite there yet in our wrangling data flows. So I say feature parity isn't quite there, but we do still have a lot of those capabilities. And hopefully, the familiarity of this environment is probably definitely a win for some people as well. On the add column toolbar, all the usual suspects. We get machine learning creeping in again on Power BI, but not there in our wrangling data flow. And then lastly, the view tab. So obviously a fairly boring one, but I think that the key takeaway for me here is that on the view, and you might have seen it on the home as well, we get the advanced editor. We get the capability to look at the M code that goes into our wrangling data flow, just like we do in Power BI. Now, of course, it's not too much of a leap to think that we do maybe a POC, a mock-up or something like that within Power BI, and then assuming we have feature parity, we could, of course, take that M directly out of Power BI, dump it into our Data Factory wrangling data flow, scale out that Spark cluster compute that we have underneath, and straight away we've got that sort of very quick heavy lifting capability from maybe that POC environment that we had in Power BI. Just an idea. What some of the more observant of you may have noticed is that within our Data Factory wrangling data flows, something that is supported, that isn't yet available, of course, in Power BI, is the ability to read Parquet files. So that's something that's really nice. So our wrangling data flows will support Parquet. Interesting one. Hopefully we'll have that in Power BI soon. So let's do what we did before. Let's take a look at our wrangling data flows. So back to our Data Factory, let's clear down our mapping data flow things. Now remember that wrangling data flows are still in preview. So I'm going to have a new pipeline. I'm going to bring on another data flow activity. and I'm going to say let's have a new Wrangling data flow. So what I'm going to do is try and recreate the same data flow that we had available and what we made with our mapping data flows now in this Wrangling world. So I'm going to add my Parquet data sets, my sales order detail line and my sales order header, all good. And I'm going to add the sync data set, which is my table in my SQL DB. And I'm going to say yes, truncate my table as well, like we did before. So if I hit OK, now I did this quite deliberately actually. The first problem we get is that it says at the moment I'm using Azure Key Vault to authenticate against my data lake data sets because we should be using Azure Key Vault. Now, unfortunately, Wrangling data flows don't currently support Key Vault backed data sets. A little annoying, but okay, we can work around that. So this was very deliberate. So what I'm going to do is in my data sets, I'm just going to update the link service to one that is authenticating, not using Key Vault. So very expected. It's a preview service, so that's fine. So let's just save those data sets and let's go back to my pipeline and let's try that again. Wrangling data flow, my order header and my order detail lines, my sync to my tails, summary table, and truncate. Okay, so now we get into the Wrangling data flow environment, and as we've already seen, very, very reminiscent of what we get in Power BI here, but of course wrapped up in this sort of data factory veneer, this data factory UI. So what I have is in my queries, I've got those two data sets there, and they are still Parquet, and you'll notice that we have read the Parquet, which is nice. And then I have my user query, so the thing that I want to then go and build. And the M for this, very simple, it's just taking, in this case, the order header Parquet file, and that's my starting point in this query. So if we try and do what we did before, and say, okay, I've got my order header, what I now want to do is merge or join those queries. And I'm going to say yes, merge it with my order details line. Let's have an inner join, and let's join on the sales order ID. 32 rows, all good. Fuzzy matching, interesting one. We don't want that. That's far too fuzzy. So, okay, we've updated. I've got my join criteria now happening. Annoyingly, though, we do get this message in our Wrangling data flows. The Wrangling data flow is invalid. The transformation logic is not yet supported. Please try a simpler expression. So I'm not going to be able to do what I did in our mapping data flows, but of course the development experience is still worth seeing. Then let's do that aggregation on my sales order number, counting the rows, nothing too exciting, and let's just hit OK on that. Which for whatever reason we haven't managed to achieve, probably because the join isn't working. So it doesn't recognize that we've got extra rows in there. It's just doing a count of the sales order numbers that we have without that sort of join to our sales order detail line. So, never mind, this wasn't ever going to work, but it was really worth just, I think, showing you what we get in our Wrangling data flows. If I hit done, it isn't going to be too happy about that because, of course, it's got these invalid transforms in it. So really at this point, I'm just going to have to either reset or just discard my changes. But it's good to see. Hopefully, Wrangling data flows are going to become GA very soon, and we'll get all of these capabilities that we're used to from our Power BI Power Query. So I'll just get rid of that. I of course can't run it because it didn't work. There's nothing there, but hopefully you get the idea. It gives you a good flavour of what these wrangling data flows are going to be capable of doing when they do go GA. Okay, let's drop back to the slides again and let's move on. So the next thing I just want to talk about is how we actually configure our data flows. And when I say configuration, what I mean is how do we define that Spark compute that we're going to go and use? Because when we have our control flow level and we have our data flow level, there's obviously a little bit of disconnection there potentially. But I've obviously drawn this in a very deliberate way. And what the takeaway here is that when it comes to configuring that Spark compute, you do that using the Azure integration runtime that you get available from Data Factory. And what you'll do is, against that Azure integration runtime, you'll define the compute type of your Spark cluster. So do you want a general purpose cluster, memory optimized, or compute optimized? You can define the number of cores and the number of worker nodes you want. So I think the smallest is a 4-core control node and 4 worker nodes. And probably quite importantly for the person paying the bill, you get to choose the time to live for that cluster. So if there's no activity on that cluster, it will kill it. So you're no longer paying for it, which is quite nice. As you may know, Data Factory by default comes with an auto-resolving integration runtime. Now, if you use that, what that will give you by default is a general purpose Spark cluster with 4 workers, and it will have 0 minutes for time to live. So just be aware that if you are doing things maybe with some big data sets in your mapping debugging environment, you might want to go and create your own Data Factory Azure IR, specifying maybe a more powerful Spark cluster that you're then going to use for your mapping data flow. Now, that's of course where you configure it, but for me there's still a little bit of disconnection there and something that I definitely want to clarify. So what I've put together for you on the next slide is a real sort of roadmap of how we actually do that cluster configuration, because I don't think it's intuitive. So what you'll need to do is within your Data Factory is go to that management panel that we get with that little toolbox icon now and the spanner on the left-hand side. You choose your integration runtimes and you potentially create a new Azure integration runtime where you define that cluster type and whether you want it compute optimized, etc. So that's all good. And what you will then do is, once you've got that integration runtime, you go into your pipeline, as you saw me do in my demo. You bring on that data flow activity, and then it's in the settings of that data flow activity that you see there. The second box is run on, in brackets, the Azure IR, and that's where you select from the drop-down list the integration runtime that you want to use. Now, that is kind of falling down the rabbit hole quite a lot. And the reason for being explicit about this is because this kind of breaks the convention of what you may be used to in our Data Factory control flow plane. Now, in our control flow plane, if we were using a copy activity by comparison, you would define that link service, you would define that integration runtime at the link service level. And then that would, of course, be determined by the data set that you went and worked with. So that's at the control flow, defining it at the link service and used by the data set. Here for our data flow level, we define it at the activity level, and that's where we do the settings. So I really want to call that out because when I first looked at this, I thought that just breaks what I understood about Data Factory with the control flow versus the data flow. So just bear that in mind. Okay, moving on. What I now want to do is kind of just try and wrap all this up and draw some meaningful conclusions from this, and hopefully just tie back to some of those questions that we've asked. So the first thing I want to say is when it comes to our data transformation tools, I've put together this short table of where I think data flows are important and where we have that distinction, because we talked about scaling up versus scaling out. And with things like our SQL database, if we were going to write T-SQL to do that same aggregation that I did in my demo, we absolutely can. But we, of course, have to write the T-SQL to do it. And that SQL DB as a PaaS resource is only going to scale up. It is not going to have distributed storage. It is not going to have distributed compute. Even with the hyperscale tier, you're only going to get read-only nodes for that SQL DB. So, given these ticks and crosses, this is the argument I want to make here for using mapping data flows. We do get that graphical UI where we can build things, and we do get the capability to both scale up and scale out that compute using that cloud native tech. Databricks, of course, and its premium features and implementation over Spark is a good contender, but we don't get that graphical UI. If we're in Databricks, we do have to maybe go and write the Python or the Scala to achieve the same transformations. We do, of course, also have to think about authenticating against our data lake storage, with key vaults, backed secrets within Databricks and using scopes and things. We have to build that plumbing in. Whereas in our data flows, we can use those data factory link services and we can build those things a little easier. So definitely things to bear in mind. Yes, these services are all capable of doing that transformation, but what do we want to use to do it? So let's revisit this question. I said to you, when should we use our data flows, our mapping and our wrangling ones, given all of this other tech that we have available within Azure? Well, the use cases I want to put before you now to try and answer this question, and hopefully some of these will ring true, and definitely what I've found in my experience so far, is firstly, SSIS developers. There's definitely a lot of investment that's gone into SIS packages over the years with on-premises SQL Server environments. Those developers, those skills are so easily transferable to those mapping data flows. It's almost the same UI and the drag and drop type interface that you're used to working with. So let's not think, oh, I'm an on-premises SIS package developer, I can't possibly do data transformations in Azure. You absolutely can, because those mapping data flows give you that capability. So that's one use case. The other use case I've seen is data engineers that want an easy ride. They want to take their Power BI Power Queries that I definitely alluded to in my demo, take that M code out of Power BI, transfer it straight into that wrangling data flow and start working with it and using larger data sets. So rather than using Power BI desktop and limited to the resources of your machine, get that code into a wrangling data flow and start using a larger Spark cluster to do those transforms. So that's hopefully another use case that I think is definitely a calling for using that wrangling data flow. Number three, and this is definitely kind of where I sit and where I've used data flows, is to do some prototyping. We need to do a POC, we need to get some data insights from our data very quickly, and we need to get it into a data warehouse so it can be used by the business or whatever. Now, rather than doing that in Databricks or doing that longhand, shall we say, we can absolutely click, click, click within our mapping data flow, get that data through and start using it straight away. So that number three is definitely me as a use case. And then number four, which I've spoken to a few data scientists about, because data scientists, they spend an awful lot of time preparing their data. They're typically working with raw data sets because there's attributes maybe in the raw level that they need to predict whatever. They might need to prepare that data. And rather than them doing a lot of codes to do that preparation, they want to focus on the data science side of things. I've said to them, well, try this out as a tool, mapping data flows, very quick, click, click, that rapid sort of delivery that we had in use case number 3. But now get your raw data in a state whereby you can use it to train your model or do whatever the prediction you need to do. So don't spend time in that preparation. So that's my use case number 4 of where I see data flows working for us in Azure. So those are my 4 arguments. Feel free to disagree with me, or if you think there's others. But what I'm going to do is, and wrap up, and final thoughts here is revisit that question of what is Azure Data Factory. And in the beginning, I introduced it as that orchestrator of some process. Hopefully now we can expand on that answer and say, well, it isn't just an orchestrator, it is that integration tool, as the marketing people told us. Fine, I accept. But it is the orchestrator of our control flow operations and potentially our data flow operations as well, using that cloud native tech, using that highly scalable tech. So it is, maybe you could say, all things to all people, and maybe, as this graphic kind of alludes to, that it really does have all of those capabilities in there now, given how Data Factory has matured over the last 4 years or so. And that is it from me, everybody. Thank you very much for listening. As mentioned at the beginning, the slides are available in my GitHub repo, in the community events repo, so feel free to go and grab a copy of them. Thank you very much.